Welcome to a technical deep dive on building robust extract, transform, load, or ETL pipelines using the powerful combination of Python and SQL. Before we dive into the code, let's establish a foundational understanding of what ETL is and why it's so vital in data engineering. ETL stands for extract, transform, and load. It is the core process that takes raw data from various sources, cleans and structures it, and loads it into a destination system, typically a data warehouse for analysis. Robust ETL pipelines are not optional. They are critical for maintaining data quality. A well-built pipeline ensures data integrity, consistency, and reliability, preventing bad data from leading to flawed business decisions. Let's begin with the extraction phase, where Python shines as the primary tool for fetching data from diverse sources. Python offers superb flexibility for extraction, whether you're pulling data from RESTful APIs using the request library, querying databases with tools like PsychoPG2 or SQL Alchemy, or reading data from various file formats like CSVs and JSON. Robustness means resilience. When dealing with external sources like APIs, pipelines must gracefully handle connection failures. Implement retries, ideally with exponential backoff, to manage transient network issues without overwhelming the source system. The transformation phase is where raw data is refined into structured, analysis-ready information, often leveraging both Python for complex logic and SQL for set-based operations. Python libraries like pandas are indispensable here. Use them for tasks such as standardizing text data, converting data types, handling missing values, and validating data structure before it hits the database. For transformations involving large data sets and complex logic, like calculating moving averages, rankings, or cumulative distributions, SQL excels. Utilize advanced features like window functions and pre-compiled stored procedures for efficiency and performance. A truly robust pipeline incorporates rigorous data validation. Implement custom checks to catch anomalies and ensure data quality. Critical failures should be logged in detail, including timestamps and row context for quick debugging. The final stage, loading, is about efficiently and reliably moving the transformed data into the target database. Avoid single-row inserts. They are slow. Opt for efficient bulk loading mechanisms, such as batch inserts using Python's database connectors, or utilize database-specific upsert functionality to handle both inserts and updates efficiently. For reliability, wrap your load operations in database transactions. This ensures atomicity. Either all data is loaded successfully, or if a failure occurs, the entire batch is rolled back, preventing partial or inconsistent data in your target tables. Building the code is one thing. Managing and maintaining the pipelines in production requires orchestration and vigilant monitoring. Tools like Apache Airflow or Prefect are essential for scheduling, managing dependencies between tasks, and providing a visual interface to track pipeline status across your entire data ecosystem. Beyond basic logging, implement a robust alerting system. This means integrating your pipeline's error logs with tools that can immediately notify your team via email or Slack when a job fails or runs unusually long, minimizing data downtime. We've covered the technical architecture of building robust ETL pipelines. Let's quickly recap the key elements of success. Remember to prioritize resilience during extraction. Utilize Python and SQL effectively in transformation. Ensure atomicity in loading, and always implement proper orchestration and monitoring. If you found this technical breakdown helpful, like this video and subscribe for more content on data engineering best practices.